Alright, let's look at Desmos and quadratic objective. So I made a feasible region, pretty simple feasible region. I've got the x and y are greater than or equal to 0, so I don't have anything beyond the x and y axis to the left or below or something like that. And then I've got a x plus 2y is less than or equal to 12, and 3x plus y is also less than or equal to 12. And so that this up here made this line, and this one here made the heavier looking line. And I just put in a quadratic objective. So you see the x is squared and the y is squared. And I've got equals z, and I added the slider, and so it just went between minus 10 and 10. Now, I probably want to change that to not a 1, a 0, because I know z is never going to be less than 0. And so that way it'll just make it easier when I move this around. Now, so suppose I want to maximize, I want to make z bigger, right? So if I want to maximize, I'm going to go like this, and you see z is bigger. But all of these values in here, they're all feasible, and I can just keep making z bigger. Right? And it gets bigger, and it keeps getting bigger, and keeps getting bigger, and keeps getting bigger. Oh, well, I can make it even bigger than 10. So let's make this as, we'll make it as big as 40. And so I just let it keep growing. It's getting bigger, it's getting bigger. Now notice this part is just now hitting down here, but all of these up here are feasible as well. So I'm going to just keep growing it up bigger and bigger and bigger and bigger. And there we go. Somewhere up in here is the optimal. That would be at x equals 0, y equals 6. So I've got, if I add a note here, I've got optimal. Well, and since we're maximizing, I'll say maximum. Maximum at x equals 0 and y equals 6. Okay, and my z value is looks like around 33. I could plug in the 6 into the y here to see specifically what it is. If y equals 6, you get 6 minus 2 is 4. Times 2, squared is 16, times 2 is 32. So actually, z at a value of 32 is as big as it can be. So trying to get it exactly right there. Okay. And it's kind of funny here because it doesn't look like that's quite going through 6, but certainly as I look at this, the picture, the last place it's going to touch is that particular corner, and it will be the maximum. And at that corner, I can evaluate this and know the answer is 32. So the graphics are just a little bit off. That's okay. I mean, it's the idea that's going on here that matters. Now, if I wanted to minimize this instead, I'd want to make z smaller and smaller and smaller. But notice I can get z all the way down to 0. Now, if I make it just a little bit bigger than 0, at 0.6, I see that it's all in there and it keeps getting smaller. And so I can take this down to 0. So adding a note, okay, minimum is z equals 0. Now, where does that happen? Well, actually, you know, for this to be 0, I would need x equals 1 to make the that part 0, and y equals 2. Now, you can't see it here, right? But you know, I can look at these and determine that that would be where z is 0. So that's a possibility, you know, for an objective. Is, you know, it may look like that. Now I can change these up a little bit. You know, I may have something like this, and in which case this changes things a little bit. Now, you know, so as I make z bigger, it does this sort of thing. So now, if I wanted to minimize z in this case, it's like right in here somewhere. Okay, because if I make z any smaller, this ellipse does not touch anything in the feasible region, so I have to make it a little bigger to get it to make it feasible. And so it's right in there somewhere. So somewhere around z equal 6.7 and somewhere around x equal 3 and y equal 1.5. Okay, so now the minimum looks to be, so if I would have to, because I changed the objective function, I changed things, so it looks to be about 6.7. I said, oh no, x is about 3.5, 3.5. You know, now I can click here, you know, and see that it's about 3.5 and 1.5. I don't know exactly what it is, but it, you know, it's really close to that. So that would be my minimum in this case. But I can make z bigger and keep things feasible, right? See, so if I do that, all of those are feasible, and that's at z equal 15. But I can keep it going. I still have things in the feasible region, still have stuff in the feasible region. Oh, clear up to 40. So let's make that 60. Now, this bottom part down at 0, 0 is just going out, but notice this top part is still working. And now that's interesting that we're going to get the same x and y values, x equals 0, y equals 6, as this thing heads out. But it's even bigger than 60, it looks like. Yeah, a little bit bigger. You know, so let's take that up to 66 or so. And it looks like it would be, oh, well, 66 isn't big enough. Let's make it 75 there. And yeah, that's too big, so I'll bring it back down. You know, and it's somewhere around, you know, here, a value of about 68. Now I know it's x equals 0, y equals 6, and I can kind of check that then. If x equals 0, that makes that 6, that's 36. So I'm going to keep track of that. I'm going to say 36. And then plus, and, oh no, I'm sorry, x, yeah, x is 0, yeah, that's right. And then y was 6. So 6 minus 2 is 4, and so 1632. Oh, and I just realized where I messed up on the other one. So so I'm going to say down here, maximum is 68, and that worked out perfectly. Now, I realized how I messed up on the previous one. Okay, so, but we see, you know, I'm just looking for when that is feasible or not feasible, and either how big or how small I can make it and keep it feasible. Okay. So now I had that as a 1, and I said that maximum was 32. I was wrong. It should be 33. So let's take this down to 33. Okay, and see at 33 it looks like it's right there, and I said 32, it doesn't look like it's there. Well, what did I mess up? Well, again, at 0 and 6, this part is still that 32, but I forgot to put in 0 here for the x. So 0 minus 1 is negative 1, and square it, that's 1. So in that case, I should have said 1 plus 32, which is 33. So sorry about that. You know, that maximum back here was, that first time was 33, not 32. My mistake, sorry. Okay, but that is working with quadratic objectives on a feasible region like this. Now, if I change all my inequalities to have one equality, oh, now I just have something like this. And again, I can look at maximums and minimums. So I'll just keep this objective function. Everything's too big right now because nothing's touching that. If I bring it in, right? Okay, everything there is too small. So I need to bring it out. If I'm trying to minimize, I want to be, come on. I guess I'm just not very dexterous here to get this down. You know, it's, well, I'm going to do it by hand here in a second. I'll get it up about, well, there's 4. Okay, so now I can do this by hand. I can change that to a 5. Oh, 5's pretty good. 5 looks like it's really close, not quite there yet, because like if I click there, I don't get any of these gray dots. You know, but I can try 5.1. Click up here. I still don't see any gray dots. I could try 5.2. Click up here. Oh, there are a couple gray dots. And since there are a couple, I'm actually a little too far, so it's probably 5.1 something. So 1.15. No gray dots, so maybe 1.6. And those there, I still have 2 of them. They're pretty close together, but I'm just going to pick one and say, okay, the maximum, or sorry, the minimum. That was the minimum because that was as small ellipses I could make. So the minimum was 5.16. And what were those values again? Around 3.2 and 2.4. So 3.2 and 2.4. Okay, so there I got my minimum. Now to get the maximum, I go out like this, and wow, it's really close. So this one I think is about touching, but this one, notice up here, I've got just the tiniest bit of room to make it a little bit bigger. And so I'm going to try that by hand again. I'm going to go with 0.3. No, that's still too small. 4, 5. I'm going to go up to 0.6. Now click here, and there is a dot. And so it's about 2.4 and 4.8. So that's what I'm going to use, and 17.6. So in this case, the maximum is 17.6, and x was 2.4, and y was, I think, 4.8. I'll click back there and see again. I think it was 4.8. About, yeah, so rounded, that's about 4.8. So you see, and this this was just a little bit too big down here. So it got kind of hard to see what the maximum was, but it was up here. All right, so that is looking at quadratic objective functions instead of linear objective functions on our different types of feasible regions.